Example 4. A function f of x is given a table below. Create a table for the function g of x equals f of x minus 3. The formula g of x equals f of x minus 3 tells us that the output values of g are the same as the output value of f with an input value 3 smaller. For example, we know that f of 2 equals 1. To get the same output from the g function, we will need an input value that is 3 larger. We input a value that is 3 larger for g of x because the function takes 3 away before evaluating the function f. G of 5 equals f of 5 minus 3 equals f of 2 equals 1. The result is that the function g of x has been shifted to the right by 3. Notice the output values for g of x remain the same as the output values for f of x in the chart. But the corresponding input values, x, have shifted to the right by 3. 2 shifted to 5, 4 shifted to 7, 6 shifted to 9, and 8 shifted to 11. Example 5. The graph shown is a transformation of the toolkit function f of x equals x squared. Relate this new function g of x to f of x and then find a formula for g of x. Notice that the graph looks almost identical in shape to the f of x equals x squared function, but the x values are shifted to the right 2 units. The vertex used to be at 0, 0, but now the vertex is at 2, 0. The graph is the basic quadratic function shifted 2 to the right, so g of x equals f of x minus 2. Notice how we must input the value x equals 2 to get the output value y equals 0. The x values must be 2 units larger because of the shift to the right by 2 units. We can then use the definition of the f of x function to write a formula for g of x by evaluating f of x minus 2. Since f of x equals x squared and g of x equals f of x minus 2, g of x equals f of x minus 2 equals x minus 2 squared. If you find yourself having trouble determining whether the shift is positive 2 or negative 2, it might help to consider a single point on the graph. For a quadratic, looking at the bottommost point is convenient. In the original function, f of 0 equals 0, in our shifted function, g of 2 equals 0. To obtain the output value of 0 from the f function, we need to decide whether positive 2 or negative 2 will work to satisfy g of 2 equals f of 2 positive or negative 2 equals f of 0 equals 0. For this to work, we will need to subtract 2 from our input values. When thinking about horizontal and vertical shifts, it is good to keep in mind that vertical shifts are affecting the output values of the function, while horizontal shifts are affecting the input values of the function. Example 6. The function g of m gives the number of gallons of gas required to drive m miles. Interpret g of m plus 10 and g of m plus 10. G of m plus 10 is adding 10 to the output gallons. This is 10 gallons of gas more than is required to drive m miles. So, this is the gas required to drive m miles plus another 10 gallons of gas. G of m plus 10 is adding 10 to the input miles. This is the number of gallons of gas required to drive 10 miles more than m miles. Try it now. Given the function f of x equals square root of x, graph the original function f of x and the transformation g of x equals f of x plus 2. Is this a horizontal or a vertical change? Which way is the graph shifted and how many units? Graph f of x and g of x on the same axis. Now that we have two transformations, we can combine them together. Remember, vertical shifts are outside changes that affect the output vertical axis values, shifting the transform function up or down. Horizontal shifts are changes inside that affect the input horizontal axis, values shifting the transform function left or right. Example 7. Given f of x equals absolute value of x, sketch a graph of h of x equals f of x plus 1 minus 3. The function f is our toolkit absolute value function. We know that this graph has a V shape with the point at the origin. The graph of h has transformed f in two ways. F of x plus 1 is a change on the inside of the function, giving a horizontal shift left by 1. Then the subtraction by 3 in f of x plus 1 minus 3 is a change to the outside of the function, giving a vertical shift down by 3. We could also find a formula for this transformation by evaluating the expression for h of x. H of x equals f of x plus 1 minus 3. H of x equals absolute value of x plus 1 minus 3.